Hello, beautiful people. Hello, my friends. How are you? So I'm fine. Today we'll be doing the linear momentum. Okay, and then today we'll be checking the few things. We'll be checking the principle of conservation of linear momentum. You must know it. You must know it. It is the total. It states that the total linear momentum in a closed system remains constant, which means what it is conserved. Okay, and then check. Today we are gonna be doing steps. The first thing that we are gonna do, I will state the principle of conservation of linear momentum, and then we are gonna be doing the followings. We are gonna do steps for solving problems on conservation of linear momentum, and then yeah, there are 7 steps, I think. Yeah, 7 steps, and then we are gonna be doing some problem types. What do I mean when I say problem types? I need to know what this is the formula for momentum. Total sum of momentum before is equals to sum of momentum after it. So it means to learn and it will be the mass times vi initial plus another mass 2v2i is equals to m1vif plus m2v2f angithi. But manje when mangithi problem types, I mean ukuthi we'll be now doing the thing whereby the object initially they are now combined. So whereby this m1 plus m2 plus vi, initially they are what? Combined. Then after the collision or after they are now separated, that's why we have plus, then plus minus plus that side. Or maybe initially they are separated, but after they are doing what? They are like maybe when a person is climbing the skateboard, when that was moving. So it is before it was the boy and then plus the skateboard. So the skateboard and the boy were not in the same let me just say the masses were not added together, but finally the boy did what? He landed on the skateboard, and then we do what? We add the masses, and then I'm gonna be doing some examples. Okay, so let me show you the steps. Okay guys, so these are the steps that you must do. We said those are the things. So these are the steps that you must follow. Step number 1, you must choose a direction as positive. Okay, and then I want to know that we are always respecting the Cartesian plane, whereby west is negative, east is positive, and then up is positive, then down is negative. So I think you must know that. And the number 2, sketch the situation. What do I mean when I say sketch the situation? I basically mean to draw a block to represent each object. If you can understand the scenario, if maybe they're saying a 2 kg block was there, draw it, and then another one, draw it, and then describe the scenario in your own, and then just think about it. And then number 3, you write down the equation. What is the equation? Sum of momentum before, which is equals to sum of momentum after, and then that is the equation for the conservation of momentum. And then number 4, you do what? You expand the equation. What do I mean when you expand the equation? You simply say where there is EPI, you put the what? M1v1 plus M2v2i, which is the initial, then equals to M1vif plus M2v2f. That is what I mean when you expand the equation. Number 5, you substitute. You put the values that must be there, and remember to check the direction of the object's velocity to use the correct signs for the directions. So be careful there. So sometimes they can say it was going to the west. So when not, don't put your 5, just say -5 as it is, because it is the west, which is what? Negative. And then number 6, what do? You calculate the answer, and then finally you get your answer and include units and indicate the direction. This is very important. Always remember to include the units in your answer, because it's very important. It has marks. And remember that the positive or negative sign represent what? The direction. Okay, so manje, let's check the problem types. We are now done with the steps for solving the problems of momentum. Let's go to the problem types. So now let's check the problem types. It is not the same. It is not gonna be always when you find your It's not like when each and every time you will find your values and then you just do it. There are different types of problems. So number one, let's check. Two objects collide and continue to move in. Two objects collide and continue to move as separate objects after the collision. Okay, so this is simple, guys. So when the two objects, so it is two objects, né? Initially they are separated, and then finally they are also separated at the same time. Okay, so what does that mean? It means you're gonna do your thing. So number one, it is gonna be EPI is equals to EPF, and then it is M1 V1 plus M2 V2 is equals to M1 V1 plus M2 V2. You see, so initially they were separated, and even after the collision, you will do the types of collision after this. So let's now work on this. So initially they were separated, and after again they were separated, which means it is just like that. Then let's check the problem number 2. So two objects collide and unite. What do I mean by that? So they collide and unite. So collide, it simply means after, because they collide. What I mean by collision, because initially they were, let's just say maybe there's an accident. Initially those cars moved where they come from, like the one maybe moves from Gauteng, the other one moves from Limpopo. But when they collided the same place. So two objects collide. What do I mean? Or collide and unite. So this one, let me show it. You're gonna say EPI is equals to EPF, and then it's gonna be N1 VI plus M2 V2 is equals to M1 V1 F plus M2 V2F. But if not, it is no longer like this, because they said and unite, which means it's gonna be M1 VI plus M2 V2 for the initial, which is now equals to M1 plus M2 times VF, because they said they collided and united at the end. Okay, and then let's go to number 3. Number 3, the two moving objects that are likely initiate, joint, and then separate. So initially they are joint, and after they separate. So two objects, initially they are joined, they are in the same, I don't know how to explain this, but take it like a boy on a skateboard. He is riding the skateboard, and then after, which is final, they separate. So the boy stopped riding the skateboard, he left the skateboard moving on its own. Okay, so it's now easy. How are you gonna put it? EPI is equals to EPF. Okay, and then it's gonna be what? Now they are joined initially. What do I mean? They are joined, so it's gonna be M1 plus M2 initially VI, which is equals to, now finally they do what? They separate. So M1 plus M1 VI plus M2 V2 final. So initially they are joined, finally they are separated. So it's going to be M1 VI F plus M2 V2 F. Okay, so let's check the fourth problem type. So what is the fourth problem type saying? The two stationary objects are initially joined. Okay, so let's write the two objects. Initially they are what? They are joined. And then let's check. Let me download and remember. They joined and then separate. Example, maybe during explosion. So they are initially joined and then separate. Okay, so how are you gonna do this one? It is the same as this one. But here, what are you gonna do? It means to go to Lana, you're gonna do the very same thing. M1 plus M2 times VI. But on the next step, you're gonna say 0, because they initially joined and separated. Maybe for example, during explosion, if there is an explosion, there is fire, so it is no longer there, and then after it's gonna be what? M2V2F. That's how we do it. Okay, let's continue. I'm gonna show you another thing. Then since they separated, is gonna be 0 and it this side. Then after it, this side it will be equals to m2v2f m2v m1vif plus m2v2f. That's how it is. Okay, so now let's check number 5. Okay, let me check what conjure is number 5. Oh, it is when an object falls vertically onto another object that is moving horizontally below it. So how is it gonna be? Remember, the object fell on another object vertically, which means going from up to down. So this is how you're gonna write it. I wanna save my time. EPI is equals to EPF. So you're gonna say M1 plus M2 and then times 0. This is for the velocity, initial velocity. Okay, and then after it is gonna be equals to, sorry, it is let me start off. M1 VI plus M1 V 1I plus M2 V2 I is equals to M1 V1I plus M2 V2 F. So guys, this is just it's too much, so sometimes you'll make a mistake by saying the F and I. So if an object falls vertically onto another, it means the velocity of the second object is going to be 0 because the object fell on another one vertically. So now we are going to be left with M1 VI because in the V2 it was 0. So anything times 0 is 0, which is going to be equals to, now check, and it fell onto another object vertically. Now after the collision, it's going to be M1 plus M2 and then VF, because check, the other one fell onto another one. So after it will be what? It will be now, they will be now joined because this one just came to the second one. Okay, so because now it is saying an object falls vertically onto another object. So that's you must know. So let's revise. So the problem types related to linear momentum. So it is when you have two objects, initially they are separated, and after or final they are separated again. So when they are separated initially and finally, you just write it like this. You don't combine, you just separate them as they are. And then problem number 2, when the two objects collide and then unite. Okay, so it means initially they are separated, they are collided, and then after it is M1 plus M2 times VF. Okay, because it is they united after. And then number 3, two objects initially they are joined, finally they are separated. So they are now added. It is going to be M1 plus M2 times VI because they joined initially, and then after, which is finally, they separate. So it is going to be like this. That's how you mean when they say they are separated. And then number 4, it is when the two objects initially joined, and then it's gonna be how I explained it. Okay, and then let's check the last one. It's gonna be when an object falls vertically onto another object. So what do I mean when an object falls vertically onto another? It means on the other object, the final velocity is gonna be 0 because it fell on it, and then I'm gonna be left with M1VI, M1VI, M1V1I initially, and then after they're gonna be joined. So let's check an example. Okay guys, here an example. So I just took it from a textbook because the question papers, they are combining the elastic and inelastic. So there's no electricity, but I'm done. A boy with mass of 50 kg runs at a velocity of 6 meters per second and lands on a 20 kg cart that was moving at 2 meters per second. Calculate the velocity of the cart and the boy if he runs from the back and jumps on the cart. So now I have my things here. I have my 6 meters per second, I have my 50 kg, I have my 20 kg and 2 meters per second. Mara check, they're saying calculate the velocity of the cart and the boy. What do they mean? It means they are now joined together. And then if he runs from the back, so Maran Manji, you have the initial velocity of the cart and the initial velocity of the boy, which means they want the velocity, the final velocity of the what? Of the boy. You're gonna do your thing. EPI is equals to EPF. Sum of initial momentum is equal to sum of final momentum. Oh, sorry guys for using a pen. I'm just trying to do my things here and save time. So it is what? Mass M1 VR1 times I plus M2 V2 I is equals to M1 V1F, which is plus M2 V2F. Okay, and then man you check, I have a boy and it which mass of 50 kg, so I'm gonna say 50, and then what is his initial velocity? It is 6. Okay, and then plus the mass of the cart is 20 kg, and then it is moving at 2 meters per second. But since they are joined, I'm gonna do what? I'm gonna say, so Lana was supposed to say what? I was supposed to say M1 plus M2 times VF, but it's fine, you are learning. So it's gonna be 20 plus 50 times VF. Then when I calculate this one, it gives me this one is 300, and then this one is 40, then this side is 70F, which is 370 is equals to 70F. 340, I mean 340 is equals to 70F. Therefore we divide by, put it by 70, and then my VF is equals to 4,86 meters per second. Okay, and then when I'm done, I continue. So you have to write the direction, so you can say in the same direction, because I'm not sure if he's moving to the west or to the right. But since you are told here, Guti, calculate the velocity of the cat and the boy if he runs from the back. So here's the skateboard, and then here's the boy. So if he runs from the there, it means Guti, this thing is going there. So and he's also going there. So everything is positive. Okay. So let's check another one. So let me show you something. Angit they said calculate the velocity of the cat and the boy if he runs from the back. Angit. So now let's change from the back and write from the front. So what is gonna change? Everything is gonna be the same. What is gonna change? It is this one. It's gonna be -6 because the skateboard is here. Here's the skateboard. It is moving that side, and the boy is also coming here because it is at the front. So this is positive, this is negative. So because it is coming in the opposite direction, then when I calculate my values, it's going to be VF is equals to -3,71. Oh, you start by doing this, -3,71 meters per second. Dang it. Then you're going to do your thing again and say 3,71 meters per second in the opposite direction. So guys, be careful. Momentum is all about the direction. If they are saying the object is moving to the east, no good is positive. Moving to the west is negative. And then if they are saying the object is going in the east, and then the other object is going to the west, you're gonna do what? It's gonna be positive and negative. If they have the same mass, you can factor out the m there and just do that.